This is HashBang, featuring interviews and discussions about the latest in JavaScript and the JavaScript ecosystem. Brought to you by OKGrow, a JavaScript consulting and training company, building software to help our clients solve problems and create opportunities. Contact us at okgrow.com.
Welcome to the HashBang podcast. I'm Paul Dowman, founder of OKGrow. With me today is co-host Robert Dickert. Robert is a software engineer at OKGrow and previously was with the Meteor Development Group. Today our guest is James Hush. James is a developer at the NFL. He focuses on JavaScript performance and developer tools, and he describes himself as the bridge between DevOps and the front-end team. Welcome, James.
How's it going, Paul? Nice to meet you, Robert.
Great
to meet you, James.
Thanks for joining us. So, obviously, the NFL is huge. Most people have heard of the Super Bowl, but that viewership is moving from TV, or at least supplementing it these days with web and mobile. And so I was wondering if you could give us an idea of how big the websites are, or the servers that serve up your mobile traffic, maybe in terms of like traffic, and also in terms of complexity or size of the code base or whatever.
Sure. We get millions and millions of hits a day. And over the last 2 years, we've been using React extensively for any new web property. And every single new web property you do, whether that's NFL.com/Game Pass or NFL.com/Now, is all inside one giant repo that's sharing React components with each other. So off the top of my head, we probably have about 10 to 15 different websites, whether that's the NFL.com/Game Pass or the Chromecast app, all in one repo. On top of that, we have legacy code, like the current NFL.com homepage that's still running on JSP, that we're looking to redesign next year, and fantasy.nfl.com, which is all PHP, that we're looking to redesign next year too. So there's a lot of code, a lot of code and a lot of hits.
Wow, that's huge. And so your whole job is performance and developer tools, and so that's cool, because I have a bit of a personal agenda for this conversation.
Sure.
I would really like to learn more about this kind of stuff. So specifically JavaScript, file and module loading, including performance, and even just how bundling works. So things like Webpack, alternatives like JSPM and Rollup. And I think this stuff is voodoo for most JavaScript developers. Most people just copy and paste some config and get it working. And I think a lot of people are feeling a little bit insecure because they don't know how it all works. I think I speak for the silent majority here, maybe. Or maybe it's just me. But anyway, maybe you could start by explaining what code bundling actually is. How we get JavaScript loaded in browsers these days.
Sure. So I work extensively with JSPM. We've been using that in production for the past year and a half, maybe a bit longer. I've used some Webpack stuff for some of our open source projects, and it's not easy. It's a lot more complicated. I don't know how it got this complicated, but it did, and this is where we are.
We were talking about how it's surprising that we could just spend a whole podcast talking about this one topic.
I don't know. I'm always the person, like I'm like the bass player for the software engineering team. Like, you don't really need me for most things, but like when you need me, you really do. like when you're playing some progressive metal or something, that's where I really shine. But yeah, bundling, basically, back in the Rails days, Rails would bundle JavaScript and the assets for you. So take all your JavaScript dependencies, all your CSS files, minify them, put them in one file, and put that in the script tag at the top of your document. And that works great. That actually works amazing for most projects. If you just do that, you're probably gold 9 out of 10 times. Where it starts getting tricky and complicated is when you're dealing with something with NFL. We don't just have one web app with one set of assets. we have a bunch of these microsites all over the place. We have some sites using Reflux, some sites using RX, some sites using MobX. We have a internal CMS that uses Twitter Bootstrap, but nowhere else uses Twitter Bootstrap. So if we just took all our JavaScript dependencies and all our CSS and put them in 2 small bundles, I think each of those bundles, it would be like 2 or 3 megabytes, and that just won't work on like an iPhone 5S while someone's watching a football game, and like they're not on their friend's Wi-Fi, so they're using like 3G. That just won't work. It loads forever. So we use bundling code splitting. We went through all our dependencies, figured out which ones we use for 95% plus of our properties, and put them in one bundle. And then we wrote some code that kind of goes through, examines our folder structure, and makes bundles based on the components too. So that gives us the power to really, really, really fine-tune bundles. I've spent hours sometimes just reducing bundle size by like 30K, 25K. But it all keeps adding up the more and more we kind of tweak it.
So what is Webpack or JSPM, for example? What do they do that's different from just concatenating and minifying all the JavaScript files together?
So JSPM is pretty cool. So I noticed online there's a lot of people, especially like some of the talks at Google I/O last year, were talking about not bundling JavaScript. So kind of like doing the opposite of what we were doing for the past 4 or 5 years. So JSPM was based on something called System.js, which is a polyfill for the system.import, which is a spec that was written a couple years ago that hopefully the browsers will start implementing. I know Internet Explorer Edge has started implementing it a bit. But what JSPM allows you to do is it builds out like a dependency map similar to require.js. So if you're using package A and it depends on package B, which depends on package C, System.js will automatically build out that tree. And when you go to the web page, it's smart enough to know, oh, we need to load package A, so we'll load B and C. Mm-hmm. And so what's neat about that strategy is theoretically with HTTP2, it will only download the bits of JavaScript that you absolutely need to run at that very moment on that page. And since it's only downloading one bit at a time, it will cache those packages too. So you don't have to worry about downloading a bundle of JavaScript, but only using like 20%, 30% of the bundle. So theoretically, that was pretty cool. We actually did that in production for a few months, set up HTTP2 on Akamai, like went all in, but didn't really work. It didn't work. Like the performance just wasn't there. HTTP2 for us wasn't as fast as everyone kind of told us it would be. So we went from bundling to unbundling, and now we're back to bundling.
So for our listeners, and just to summarize, like HTTP2, the major change with that is that you can download multiple HTTP or multiple resources from the server in parallel, or reusing the same connection, potentially in parallel, I think. And so I guess that's why it would make sense that you don't necessarily have to. One of the reasons to, ever since back in the Rails bundler days, and that was one of the first things, but there were others that did this, which just minified and concatenated all the files together. One of the reasons to do that, I guess, is because then you only have one HTTP request. Mm-hmm. So, but with HTTP2, you can effectively have the same. You can reduce that network overhead. So that's the idea. But you found it didn't work out.
Yeah, it didn't work out. It was a combination of HTTP2, at least for us, didn't quite deliver as much performance as we thought it would. And JSPM itself, the way it kind of works, and I learned a lot about how it worked, which is terrifying. No one should know this. But the way it works is, at least for common JS modules, which you get from NPM, I went through the source code and found that I was running it through an eval statement. So it would send an XHR request to get the dependency, grabs the dependency, and then in order to load it in the browser, it runs it through an eval statement. And that takes a few milliseconds to run, which does not seem like a big deal at all, but you multiply that by, especially in JavaScript land where everything has like 10 different dependencies, it starts adding up. And you can see if you open up the network panel on Google Chrome, you can see almost like a waterfall of network requests. So instead of them all downloading at the same time, it would download one, load it, see that it needed another dependency, then download the next one, load it, and then you have this kind of waterfall, which was really slowing us down.
So is that also partly because maybe they don't get loaded until they're accessed in the code, or like could it maybe also help to sort of just reference them all at the beginning somehow?
So you can reference them all at the beginning. You can write the dependency map to a file called system.config.js, and so we were trying that out too. But then the problem we were having there is that dependency map file is like a blocking, it's a blocking JavaScript load, and that was getting up to like 35K. And on 3G, we'd have to kind of like wait for that to download, and then it would like start downloading everything else. And it was just like even when we wrote out all the dependencies out first, since it was a blocking load, it would cause everything else to load slower too.
Cool. So what did you switch to? What are you moving to for instead of that?
So currently, we're still on JSPM. We've invested a lot on JSPM. What we ended up doing is we're using JSPM's bundler along with a script we created that lets us really fine-tune the bundles. Like it kind of goes through all our folders on the code base and smart enough to know like, oh, this is in components / React Helmet. So it goes through and bundles that together, and it'll bundle each one of those together. So we're using that with a couple of other. We're looking into Rollup too, but I haven't quite gotten that working. And we started looking into potentially moving back to Webpack. So over the last couple of weeks, my coworker has a version of NFL.com that kind of runs on Webpack, but it's one of those things that grass is not greener on the other side. Like you run into a bunch of trouble with JSPM only to go back to Webpack and realize like that's really complicated too. So we haven't got to a point where we've definitively made a call whether we're going to move back or not, but we're exploring that right now.
Cool. So Webpack is complicated. I hear that.
Yeah, and their docs, they don't really have docs. Well, now that the release candidate's out, they said they're going to spend some time on documentation, which is great.
What's the aspect of Rollup? What are you using Rollup for in your new architecture?
So I've tried to use it as a plugin. So right now we're on JSPM 16, and there's 17's in beta right now. 17 has the Rollup support. What Rollup does is if you're using a library that uses the new ES module imports, so the new import syntax that React's been using, it's smart enough to statically look at all your imports and then only import the chunk of code that you're actually using. So if you're using something like a big date library and you just need to use the function that converts the date from like American format to Canadian format, instead download the whole date library and putting it in the bundle, it'll only take that one function of like a 20-line function. So it looks pretty cool.
That's what we call tree shaking, right? That's what tree shaking refers to.
Yep.
Do you have an idea of how much you might save by using that?
So I tried it. We're working on an open source video player. It's not out yet. It's going to be out in the new year. We're using it on NFL.com right now, but we have some proprietary code in there we have to kind of pull out first. And so I spent the last couple of days trying to optimize that, making that as fast as possible. And for that one video player component, I managed to reduce it by about 20%. So that looks potential. And for something like NFL like the web project that contains all our new websites, like if I can reduce it by 20% on this one little library, I think I can make some pretty big gains on the whole project that's using 20 plus dependencies. So it's worth looking into. But it's tricky to set up. I'm getting some weird errors, but everyone's getting weird errors.
So Rollup, you're using Rollup with JSPM. Okay, so maybe we need to set a little bit more baseline like knowledge on the tools here,
Sure.
Because I understood Rollup was actually like an alternative to Webpack. So like, which of these things are JSPM versus Webpack are complete alternatives? Like, it doesn't make sense to use one with the other. Like they'll be sort of like competing solutions. And I thought Rollup was also a third, but so you're saying that you can use it with JSPM. Can you also use it with Webpack?
You can use it with Webpack too, and you can use it with JSPM 17. So both are like the brand new ones.
Okay.
So you can use it. You can use it as a plugin. Everything's a plugin now, so that's why it gets kind of confusing.
Okay.
I believe you can use it on its own too, but I'm pretty sure most people are either using it with JSPM or Webpack.
Okay. So there's a lot of obviously you spend your entire day figuring out the configuration and this kind of stuff. So you guys have a project, React Wildcat, that is an opinionated tool that includes basically the way you guys do stuff. Do you want to explain that a little bit better than what I just did?
Sure.
It sounds like something that maybe the rest of us could use to learn from to take advantage of what you're doing and not have to reinvent all of this.
Mm-hmm. So React Wildcat powers all of any new website we've made in the past 2 years. It handles server-side rendering for React apps. It has all the logic we use to like wire up Mocha and Protractor and Istanbul for the code coverage. It has every single little optimization we did with Babel and ESLint. Like we have a patch in there that splits up Babel and ESLint onto every single core on your computer. So it's like speeds up build times by about like 18-20%, which was pretty cool. And also has logic to let you host multiple domains all in the same repo. So one of the big problems to solve for us is we had www.nfl.com and some sites on there. And then we also have like chromecast.nfl.com and amp.nfl.com. And so that we tied that together with a React Router to make it easy to host multiple domains on the same service.
That's awesome. Okay, and so there's some stuff that you touched on earlier about not reloading the same asset multiple times. So you've got all these different websites, but if you visit one and it's got a bundle, or if it includes say underscore or some common date library, then if you move over to one of the other sites, you don't want to have to reload that. So how do you guys manage that?
So we have we kind of split it up in different bundles. So we have one bundle that we call Bootstrap that has pretty much every dependency that we know that 95% of the pages are using. So once a user goes to, for example, nfl.com/Game Pass, they'll have this Bootstrap bundle with little hash on it. So if we ever update it, it'll bust the cache. So if they go from nfl.com/Game Pass to, for example, nfl.com/Anthology or nfl.com/Now, they'll already have that Bootstrap bundle on their cache. And not only is it on their cache, but we also set up service workers on every single page. So it's also in the service worker cache. So for example, if you go to NFL.com/Game Pass, load it once, and then turn off your internet connection and load it again, you'll still get instead of getting a 404 page, you get like the application shell, which is pretty neato. And so once they download that bundle once, it stays with them as they go through each site, which means they don't have to download again, which speeds up page performance.
So each site references that one bundle from some common place?
Yep. So each site references that bundle. JSPM, we load JSPM on every single page. And that's what kind of keeps everything together. So JSPM has a config file called systemconfig.js that has that map. So it says, Bootstrap bundle contains these packages. Game Pass bundle contains these packages. Mm-hmm. What's another one? Bundle C contains these packages. And JSPM is smart enough to say that when you load NFL.com/Game Pass, it thinks, okay, what do we need? We need React. Where's React? React's in Bootstrap bundle. Let's download the whole Bootstrap bundle. Mm-hmm. And then says, what else do we need? Reflux. It's in Bootstrap bundle. We've already downloaded Bootstrap bundle. Don't need to send an XHR request out. And then if you go from Game Pass to Anthology, it'll say, what do we need? We need React, already in the Bootstrap bundle. We need this library, already in the Bootstrap bundle. What else do we need? We need RX. RX isn't in the Bootstrap bundle. Where is it? It's in this other bundle. Download other bundle.
Yep. Cool. And is the deployment of that all taken care of by? Does JSPM handle like a build step as part of your deployment, or how does that work?
So we made our own build step. Yes, JSPM handles that. So there's two modes you can run JSPM. You can run JSPM where it transpiles everything on the fly, mm-hmm. which is really handy for development. This is actually one of the problems JSPM solved for us. When we were using Webpack before, like 2-ish years ago, we'd have to wait for the whole web project to build before we could use it, which took like a minute and a half. So we run JSPM in development mode and transpiles everything on the fly. So it only builds exactly what you need in that second. So it means that instead of waiting a minute and a half, developers wait like 2 or 3 seconds to get it booted up, which is great. Sorry. You're talking about the production step. So the other mode lets you transpile everything in advance and save it in like a dist folder or like a public folder. Yep. So during our build step, it goes through, builds all the bundles, transpiles all the code. I think the whole build process takes probably close to 8 minutes or so, 8 or 10 minutes.
Wow, that's huge.
Yeah. So when I'm stuck on like making the build process better, those are kind of annoying days. Like when I'm on the last 2% of the project, just working on the build step. It's
that
a lot
famous
of
XKCD comic. Some people know what I'm talking about here.
Waiting for code compile.
Yeah.
I'm a lot chattier those days.
Awesome.
What's your process look like when you're trying to optimize that?
When I'm trying to optimize like the build times,
right?
So I can kind of go like, I look at the different build steps, and depending what step I'm trying to optimize, that's when I know when I can just exit out. The days that are kind of annoying are the ones where I'm trying to optimize the very last step, which is the transfile step. On our to-do list, we're gonna think of a way that will allow us to build only a chunk of the site instead of the entire thing. That's something we're gonna work on next year. Because right now we have a custom build and bundle script that builds and bundles everything. So we're going to figure out a way to pass in a flag. I'm totally going to do that next year because the last couple of weeks has been kind of annoying.
And how are you profiling it? Are you using any special tools?
So for profiling the build times, we're actually just running the bash time command. right before it, and that kind of tells us how many seconds has passed, which is kind of cool. But we're not doing anything more complicated than that.
And what about load times in the browser?
Load times I live in the Chrome developer tools. Like I'm there, because I've also used it to figure out memory leaks in Node. So I've clicked on probably every single button on that page. The Chrome developer tools and using. Are you familiar with JMeter?
Yeah, JMeter. I think that's if it's what I'm thinking of, it's a Java-based tool. But can you explain what it is for us?
So JMeter is I think industry standard for load testing, and it's a Java-based tool with probably the worst user interface I've ever experienced in my entire life. It's extremely hard to figure out how to make a new anything with that tool when you first start using it. So you really do have to find a buddy at work who's used it. But once you get the hang of it, it's really, really powerful. I only use about $2 worth of it. All I do is load a CSV of URLs and make it go through each URL. But you can do a crazy amount of things that I haven't even touched yet. But I was actually using it to help figure out a memory leak. So a couple months ago. So what I'd do is I'd use log into App Dynamics, which is kind of similar to New Relic. Grab a bunch of traffic history for 2 hours during a football game, put that in a CSV file, load it in JMeter, and then just send out a ton of requests from my local machine to my local server, and just watch the memory go up and down. And as I made changes, just blast it again for another 5 or 10 minutes and saw if the memory raised or lowered. And using the Chrome developer tools, I was able to hook into the Node.js process that does the server-side rendering and print out a heap dump over time and see the difference between two heap dumps, and that helped a lot.
Cool. So you replayed live traffic and then use that to debug your memory leak. That's awesome.
Yep.
Cool. Your team's lucky to have somebody dedicated to solving this kind of stuff, so normal people can just get on with getting work done, eh?
It's because I'm Canadian, so I'm just really polite. I'm like, hey, so as long as I gotta live in California, I'll work on whatever.
Excellent. I should have done that.
Yeah. What advice would you give to people who are working on much smaller sites? What lessons can they glean from what you're doing, or what things should they just avoid?
Man, just avoid. Keep it simple. Just keep it as simple as possible, because it gets really complicated really fast, and not even cool computer science. I'm using these algorithms to solve the problem complicated. It's just complicated as in, this person who posted this blog post on Webpack posted it 6 weeks ago, and 3 weeks ago they changed the API. Now this is why your code's not working complicated. So for smaller stuff, use boilerplate things as much as possible, especially for smaller projects, internal projects where not a lot of people are using them. Don't even worry about performance. Just ship it. Make sure it's providing business value for someone, because you can. I spend all day just on performance, but it makes logical business sense for NFL. Yep. If a page takes too long to load on someone's phone, they're going to exit out and go to ESPN.com. That happens.
Yeah.
So for smaller projects, keep it as simple as possible. Don't just use Webpack or JSPM because it's cool, because it stops getting cool really quick.
I totally agree, and that's what we advise our clients. We're not going to solve a performance problem until we hit it. But actually, we've avoided almost all of this because we've been using Meteor for the last 3 years, and Meteor has its own build tool, and it's very simple to use. A lot of people have been moving to Webpack just to get faster performance with hot module reloading and things. Although Meteor has been improving the performance a lot of their live reloading. But yeah, luckily we've kind of avoided most of the complexity. But one of the things that the Meteor build tool doesn't do is allow you to split code split based on a route. So for different, so for example, for a Meteor app, as they get big, I mean, not just medium size, but we've worked on some client projects that over time got very large in terms of code size. And the main performance problem that you run into is just the size of the JavaScript bundle, because it's always one bundle. So do you guys do anything with, first of all, what router do you use? Is it React Router?
Yep, it's React Router, I think 3, not 4. It's not the newest one. It's the one right before.
Okay. And so how do you split your... Oh, well, you use JSPM. So I guess JSPM, that solves that for you.
Yeah.
And
we split it by dependency instead of route, basically.
So does that mean as your code loads a different module, maybe it's because you went to a different route, or maybe it's just because you did something on the page that caused something to be referenced?
Yeah.
Then you cause the next module to be lazily loaded?
Mm-hmm. So it'll either, if you don't have any bundles, it'll cause the next module itself to load. Since we have bundles, those get written to a config file, and JSPM sees the modules in that bundle and tries downloading the bundle.
Okay. And do you know can you do that same thing with Webpack as well? So in your new way of doing things that you're going to move to, will you still be able to do that, or will that change?
I think that will change. I can't recall off the top of my head, though. I think with Webpack, it does it by route instead of by... because Webpack doesn't have that. It doesn't print a dependency map, does it?
I don't know.
I don't know. I don't know. I know.
We avoid the whole thing by using Meteor and not having bundles at all, which is occasionally a problem.
Occasionally. Yeah. And then when it's a problem, you go fix it.
When it's a problem, it's a big problem. That's the thing. Like 99% of the time, it's fine. But or it's fine up to a certain stage. And when your app reaches a certain size, it becomes a problem. I mean, there's definitely other things you can do. Make sure that you're not referencing things that you're not using. Reduce the size of your templates, because templates end up as code. So we sometimes do things like making sure that if there's a lot of static content, that it's not part of the template, that it's kind of treated more like data and gets loaded as data. But yeah, but there's a point where your app bundle just gets large and you can't do much about it. And at that point, it starts to make sense to look at alternatives like Webpack. So when it comes to optimizing things for performance, for loading JavaScript, is there one thing that you've done that is kind of a crazy performance hack? Is there any one interesting thing that you want to tell us about?
This one sounds so. This goes back to me just being like, just keep it as simple as possible. But like using a script tag instead of using JSPM to load something or Webpack to load something has been like, it's amazing how much faster it is to use a script tag than to use JSPM. A good example is this on the NFL Chromecast app. So if you try to watch NFL on your Chromecast, I was working on that project, and we're in the last couple of days, and we're trying to speed it up because it was slower than the old version. So we added an original version of the Chromecast app, and then we migrated over to Wildcat using React, and the load time was slower than the original. And so we said, we can't have that. Like, that's going backwards. So what we ended up doing with a couple of Chromecast dependencies was we threw them in script tags at the top of the document, and it loaded like almost a second or so faster. So that's
amazing.
Like, surprising hack.
That's a big deal. 1 second, yeah. That's cool.
So yeah, whenever possible, just use what the browser's already using. Like there's like the developers on Chrome and IE and Firefox put a lot of time making sure the native stuff runs well. and it runs a lot faster than loading the code through an eval statement or anything like that. So like the best things to speed, I found like some of the places where I got the biggest speed gains were in some of the like most obvious places. So for example, going back to about a year and a half ago, when we had everything unbundled, just going back and bundling stuff gave us a bunch of speed gains. So don't be afraid to do things that seem obvious and like seem like old. Like that usually will give you your biggest wins.
Awesome. Well, Robert, do you have any other questions?
This is actually a little bit off topic maybe, but I'm
Sure.
just curious about your experience with service workers and how that's affected your code base. And can you use that on all browsers?
So you can use it in Chrome and I think Firefox. And I can't recall if you can use it in Internet Explorer. If you can't use it in Internet Explorer right now, I know they're planning on working on that. Safari and mobile Safari, Apple just does not like developers. They just don't want. they have zero incentive to make their browser good on iPhone because they want people to keep using apps, and service workers can make a web app seem like almost like a native app. So it works on most of the browsers, and the browsers it doesn't work on, it doesn't make anything worse. So what we had to do for our code base was we had to make kind of like there's a library Google puts out called Service Worker Toolbox, SW Toolbox or Toolkit. That will kind of generate, it has a nice little config file, and it'll generate the code you need to get service worker caching working, which is what we use. That's kind of the big one we got from service workers so far. So that allows us to do things like if you go to NFL.com/Game Pass with no internet connection, it still loads the shell. If you go to NFL.com/Now, you can add it to your Android home screen, and you get a little NFL Shield logo on your home screen, and it'll give you push notifications. So,
Oh wow, that's cool.
yeah. There's a couple talks at Google I/O last year on it, and they're really pushing them. And like you can get some really cool performance gains with service workers. Actually, that's something I should bring up. So if you've already tried doing the obvious stuff, like trying to get speed of JavaScript, take a look at SW Toolbox, Service Worker Toolbox. I think that's the name of it, and experiment with adding caching to some of those JavaScript bundles. Because that way, if someone's internet, once they go to your website once, it'll improve like page loads across the board throughout the rest of their like experience on your site.
Awesome. Well, I think that feels like a good place to leave it. I've learned a ton. Do you have anything that you want to mention? You guys have a bunch of open source projects and things that are really cool for React. You want to tell us, just mention what those are?
Sure. So the one I work on, I'm a core contributor for React Wildcat. If you're using a production level like React app and you want to see how to get server-side rendering working and all the stupid stuff that prevents you from actually writing code, take a look at that. We use it for all of NFL.com, so we're not abandoning it anytime soon. And we also have another popular library called React Helmet that almost has 3,000 GitHub stars now, which is pretty neat.
Nice.
And in the new year, we're going to be open sourcing a video player. It's the same video player that we're using for NFL.com. It'll have like social share buttons, a carousel. Like it's cool, and it's all with React. So I'm excited for that. I'm working on that right now, trying to rip apart the proprietary code so we can open source it in the new year.
Do you have any comments on server-side routing? Like what special sauce did you have to put in to make that work the way you wanted it to?
So server-side routing is tricky. Server-side routing with JSPM was a lot trickier. Luckily, my coworker Rich, he's like smartest engineer I've ever worked with. Insane. He's the one who figured that out. We had to like override a couple of the loader functions on JSPM to get it working, but we got it working. Server-side routing like gives you a nice performance increase, but it also helps a lot with search engine optimization because instead of just loading an empty div to a search engine, it actually loads all the content.
Right.
But getting it working with React is not easy. So you should look at Wildcat. Angular 2 has something called, what's it called? Angular, I forget what it's called, but Angular Universal, I think it's called. So Angular 2 has their own server-side routing thing. I think that works out of the box, but I haven't really played around with it too much yet. But yeah, the other trick with server-side routing with React is you kind of have to go into a project saying that you're going to do server-side routing. It's really tricky to convert a React project that wasn't already set up for server-side routing.
Is that because of the rendering, the data hydration, or is it something completely different?
No, yeah, it's because of the rendering and the data hydration. Unless you start a project like with that in mind, you kind of have to go back and undo a lot of stuff and erase things and change them up.
So does it help then having a centralized store? Like I guess you guys use MobX or Redux.
So we're using Reflux for some of the stuff we did about a year and a half ago, and RX on Game Pass and MobX on everything we've done over the last 6 months, or 5 or 6 months, I'd say.
So the server, just to like clarify in my head how this all works, the server renders the page on the server side because we're using Node. It's got a JavaScript process, and it actually uses the same data store or that you'd be using on the client. It actually runs it there, fills it up with some variable values for different attributes in the page. Then it actually serializes that, sends it over with the page, and then you deserialize it in your Redux or MobX or whatever data store is already set up without having to rerun that same stuff on the client side.
Yep, and then the moment it hits the client, it turns into a single page app. So from that point on, JSPM kicks in on the client side, and as you can actually see it in the network tab as you're going to the NFL sites. As you go on like Game Pass and you click from the next page, it sends an XHR request and pulls in the next chunk of content.
Very cool. All right. Well, thanks, James.
No problem.
If people want to follow you or check out the work that you've done, where should they look?
So I'm not cool enough for Twitter. I couldn't figure it out, but NFL Engineers, if you go at NFL Engineers, any cool thing I do, I usually just get my coworker to post on there.
Awesome.
So that's the main one.
Very cool. Thanks, guys.
Thanks very much.
Okay. Talk to you soon.
Thank you.
See ya.
Bye.
You've been listening to HashBang, brought to you by OK Grow, a JavaScript consulting and training company. Contact us at okgrow.com.